Hello again, guys. We are here to begin Chapter 6, talking about frequency and histograms. So we are going to first talk about frequency tables. This just has to do with organizing your data into easier to see situations. So here I have an example of both a frequency table and of a histogram. As you can see here, frequency table will give you pure data like numbers, and a histogram is more like a bar graph like you've seen. It visually represents the data so your brain can kind of compare. Work through problem 1 in Pearson, which uses this set of data and this frequency table, and then when you're done with it, we're going to come back here and we're going to use the same data but in a different way. So hopefully you worked through problem 1 and understand how we created that frequency table. We're going to work through here now, and we want intervals of 5 for our frequency table. So again, you would want to take your data and sort it into the correct order, which actually, if you look back at problem 1, I think is the first thing they did. And then we want to take our first value and create intervals of 5. Think here to yourself, can there be more than one starting value, or is there one point where we have to start at? So our answers could vary because we could have more than one starting value for the first interval, because we could go ahead and talk about how many batters hit 0 runs and 1 runs. So you could start at 0 or 1, but if we want to start where we need to start our data, we can start at 2 and do 2 through 6, which is 4 runs, and then you see as we go up from here. I do have to correct over here, I had a typo. It said interval of 3. Because I quickly wrote that, and 5 minus 2 is 3, but here it's actually an interval of 4 because it is including 2, 3, 4, and 5. So my interval here is 5 because it includes 2, 3, 4, 5, and 6. Go ahead and try practice problems 1 and 2. Make frequency tables for the data here with our marathon times and our top speed miles per hour. Alright, so the first thing we do for number 1 is we list all of our data out in order from least to greatest, and then we choose an interval. Here I have decided to choose an interval of 20, so that tells me to start, I choose to start at 130 since I have a value of 135. I don't want to start right at that value because I like to start at intervals of 10 normally. So I go 130 to 149. Now I'm not going to include 150 because it's going to fall into my next category. And if I delete this whole thing, you can see our entire table as follows. For number 2, same thing down here. I did not list this out in order for you, but you can see going from 90 to 109 is still an interval of 20, and I have 4 that fall into there, and so on. Alright, this definition of the histogram accidentally got left out of your notes, so if you are having a hard time remembering what a histogram is, here's your definition that you might want to jot down in your own words in your notes, and then do problem 2 in Pearson and come back when you're ready to check your answer for the got it. We're going to be making a histogram that represents this data here. Alright guys, so the first thing we want to do on this got it, just like any time we're making a frequency table or a histogram, is to sort my data so it's in order from least to greatest. So if you have yet to do that, go ahead, pause the video and take care of that right now. Once my data is sorted, it is going to look just like this, and you always want to check and make sure that you have as many terms in your sorted data as were in the original. There were 13 terms up here, and there are 13 terms in my sorted data. And let's go ahead and choose a data interval of 10 for our histogram. So if we start at 80 and we see how many are in the data range of 80 up to 90, but we can't include 90 because that'll fall in my next range. So then I look at 90 up to 99, then I go from 100 up to 109, which only takes me up to 105 actually. Now to answer my plan over here about how we could use a frequency table, we essentially have made a visual frequency table here. We could sort our data and literally write out how many terms are in each, or we can just count based on my highlighting. So go ahead and make the histogram if you have not done so yet. So here we go. Our frequency is always on the y-axis, and whatever our variable is goes on the x-axis. Our times were what was varying. And of course we want to show here that we have a broken graph because I skip right up to 80, and I am not correctly showing the distance, since now I have these distances representing 80 to 89. And you want to make sure your bars are always the same width. That was one thing I wanted to point out up here. Our bars need to be the same width since our intervals are going to be the same. Go ahead and create histograms for practice problems 3 and 4. You want to make sure that you start by sorting your data, then choose an interval that makes sense. sort based off that interval, count how many you have, and then make the histogram to match. So intervals of 10 work pretty easily, especially when my data has a nice range like this, being from 0 to 60. So I go ahead and make a histogram that looks just like this. On my frequency, I only go up by 1 because my frequency, the max frequency that I have here is 4, so I can say I don't need to go up by very many to be able to graph that. And you see we have a lot of bars that have the same frequency. That will happen sometimes depending on how spread out our data is. When we look over here at number 4 for points per game, it's a little bit more spread out with my frequency. Our max is 10, so we decided to go intervals of 2 for my y-axis showing the frequency, but we still take intervals of 10 for my points range. So when we talk about histograms, we have different ways that we talk about them. We have a uniform histogram, which is where most of my frequencies are pretty similar to each other. We have a symmetric histogram where it kind of makes the nice curve of our highest frequency will be in the middle of my data range. And then we have a skewed histogram where my data kind of might go up and then drop all of a sudden, or my data might just be all over the place. It just really isn't uniform or symmetric. So make sure that you've worked through problem 3 to get to here, and then go ahead and sort the data and make a histogram to represent Jay's amounts that he has spent on lunch. Alright, so now when we have the histogram for Jay's lunches, it will look something like this, and that is a fairly uniform distribution of how much he spent, since all of my frequencies are the same up until this last bar, and it's still only 2 away. So now when we're trying to predict how much money should Jay plan to bring for lunch next week, you know, our answers are going to vary a little bit, but 70 would be pretty safe. On average, he's spending around $10 a day. So go ahead and determine based on the distribution of the frequency whether the histograms here are uniform, symmetric, or skewed. So my data in 5 goes up and then down and then up again, and it's kind of all over the place, so we can say that 5 is skewed. And then my data in 6 has a nice little curve that it takes. It goes up, has a central distribution in the middle, and then goes back down, so we can say that that is symmetric. So now we want to talk about what it is to make a cumulative frequency table. So cumulative frequency table is only going to be different because it has an extra column on the end that shows you the total amount of data up to that point, or how much is less than or equal to that much. So go ahead and work through the next problem in Pearson, make sure you understand all that, then come in the Got It and try to make a cumulative frequency table for this data. So pause the video, come back when you're ready to check your work. Alright, so my cumulative frequency table here, I decided to use intervals of 5, so I started with 0, 1, 2, 3, and 4, then 5 to 9, 10 to 14, 15 to 19, and if I want to show the cumulative, how many people are from 0 to 19, that is shown right here by the 16, but of course we probably wouldn't need to know that because that's our entire range. So let's try something like how many people are from 0 to 9, or what's the distribution? Well, that would be 10, so you can always look in this last row to find out the total, combining everything up to that point. In 7 and 8, go ahead and quickly make cumulative frequency tables for these sets of data. The differences I use for my table here for heights of building is 50, and then I use a magnitude range of 1. So my frequency there from 100 to 50 is 2, so my cumulative frequency is 2, but then as I go up, I get 3, so now my cumulative is 5, and so on. And then I can do the same thing for my earthquake magnitudes. I start and I have a magnitude or a frequency of 7, then I get 4 more, so my cumulative becomes 11, I get 1 more, cumulative becomes 12, and then to finish us off, I have 13 total values. So in 9 through 11, you want to make a frequency table, a histogram, and a cumulative frequency table. So honestly, you can combine 9 and 11 and just make one cumulative frequency table. And your answer is going to vary depending on the range. So pause the video now and then come back to check based on the ranges that I use. If you'd like a hint, I have ranges of 4 and 9. And ranges also of 4 here because the histogram is just showing the same data as the frequency table. So hopefully you did this on your own now. My distribution or frequency here goes 7 to 1, 2. So as you can see, the primary amount is here in 9 to 12, which is going to be shown by my histogram by the taller bar. And my cumulative frequency table is showing all the totals all the way up to the 12 total data points that I have. So really the two main answers that you want to have is this table and this histogram. I believe, yep, that is all I have for you guys today. So please make sure that all of this makes sense. If you have any questions or concerns, please let me know, and I will see you guys in class. Thank you.